Thank you for waiting out the technical difficulties. So yes, I really like desserts. I guess the other thing I could say is that I'm writing a book on code reviews, and I'm on that last 10% that takes 80% of the time. So come find me if you want to talk more about that. But today we want to talk about invalidating idempotency. So I commend Katie for saying the word. I didn't know how to say it either until I started looking into this and researching for this talk. But why this talk? Where did this come from? A lot of the topics that I come up with usually start with conversations with my husband. He works for a very large company, and he deals with scale that I have not personally dealt with before. And so whenever we start talking about problems that he's dealing with or problems that he's trying to solve, it always deals with tons and tons of scale, like hundreds of thousands of transactions per second, something that I, again, have not personally worked with, but it just boggles the mind. And so naturally, when you start talking about that kind of scale and doing that many kinds of requests per second, you get to thinking about a lot of different things. And one of those things is idempotency. So, idempotency. What we're going to go through here is idem what? What exactly does that mean? How do you pronounce it? Where does it come from? What does it mean in the context of tech? Then we're going to see why does idempotency matter with good architecture. Then we're going to actually see what elements of idempotency make it idempotent. So what are the key things that you need in order to make something idempotent? And then finally, I'll share with you some tools that you can try if you want to try making your requests or APIs or functions idempotent yourself. So, idem what? Idempotency. It is not a real word, according to Merriam-Webster. This is a thing that the tech world just kind of made up, co-opted, I don't know. But when we look here in a different dictionary, we see here that it says idempotent is relating to or being of a mathematical quantity, which when applied to itself under a given binary optionation represents itself. But in the great words of Kevin from The Office, why waste time, say a lot word, when few do trick? That's too complicated. So instead, I decided to use this particular one, which is another dictionary, and that just means unchanged when multiplied by itself. So if you think about multiplication, 3 times 1 is always going to be 3. 4 times 1 is always going to be 4. If you do this, and that quality, that characteristic of having it be unchanged every time you run that particular operation, that's what idempotency is. And so the tech version of that now is whenever you run something, given the same inputs, remember when you run this over and over, that it's going to remain the same. It's going to stay unchanged. It's going to give you the same output. So no matter how many times you run something, and given the same inputs, it remains unchanged. It gives you the same output. If you were in Rozelle's talk earlier, where she was like, please, I hope that Copilot helps out and does what it's supposed to do because it's not deterministic, this is kind of the opposite of that. We want to kind of assure that what we get is always the same at the end. And so idempotency, that's what that means, even though it's not a real word. So now you're like, all right, that's great, Adrienne, but what does idempotency have to do with good architecture? Why are we talking about this? And I'm going to be one of those people that's like, well, everything. But also, have you heard about the 7 design principles of well-architected applications? Who here has heard of this? A couple hands, OK. So this will be a quick primer. For those who haven't, I have permanently borrowed from Amazon these 7 design principles of well-architected application. And for this particular one, they have different lenses with which to look at applications through. This one is the serverless lens because I think it's appropriate for this talk. So very quickly, there's speedy, simple, singular, meaning focusing on doing a single thing at a time. sharing nothing, specifically in serverless, right? If you're using different servers, you don't know which ones you're going to come across or use, you want to assume that it's not going to keep any kind of state or share any kind of information in between those servers. You want to assume no hardware affinity, same thing. If you choose to use serverless, you're choosing not to care about the hardware at this point. You want somebody else to take care of that, so you just want to keep that in mind. You want to use events to trigger transactions. Instead of having something, one function trigger another function, you want to abstract that a bit by using events. You want to think concurrent requests rather than total requests. Whenever we think about something like this, sometimes we kind of think about what are the total numbers of requests we have that's happening in this application. But if you're using something like a serverless solution, you want to take advantage of the horizontal scale that you would have available to you. So in that sense, you might have to tweak your mind a bit and think concurrent. How many can you do at the same time rather than just the total number of requests? Other thing, orchestrate your application with state machines, not functions, which is quite similar. You want to have some sort state of truth, source of truth is what I'm trying to say, sorry. One single source of truth that kind of directs the way your applications are in terms of state, and then this one. Those are all just primer. This is just to tell you what the 7 are, but this is the most important one here. Designing for failures and duplicates. Why? Because without idempotency, this particular thing, this principle that we want to hold dear in all of our applications, is impossible without idempotency. And I want to show you why. So designing for failures and duplicates. Werner Vogel himself said, everything is going to fail all the time, something like that, paraphrasing. But failure is always going to happen. If we keep that in mind, we develop our applications with a little bit of a different mindset, because instead of trying to just skirt through and go through the happy path, when you think about, oh, this is definitely going to fail, you think about edge cases, you think about error handling, you think about how do I deal with that failure that's definitely going to happen. Failures are going to lead to retries. Who here has solved a problem by trying something again, resending something, turning it on and off again, mashing the F5 button? And sometimes it works, right? Sometimes the weirdest edge cases, sometimes the most random problems that you have, they will just be solved by retrying it. So keeping this in mind, knowing that this is something that is a fact, now we have to start thinking, well, if we know retries are going to happen, if we're going to absolutely have retries as part of our toolbox, then we need to also know that implementing retries means duplicates can and will occur. So if we are the ones now building in and saying, yes, let's put in something that actually retries this function or recalls this API, we're the ones introducing our own problems, right? We're the ones that are potentially introducing duplicates into our system because we are the ones implementing the retries. And that's okay. Now what we have to understand is if retries are going to be a thing and duplicates are things that we're definitely going to introduce because we intentionally do that, if duplicates occur, then idempotency is key to mitigate the side effects that will occur with idempotency. So side effects. What are side effects? Can anybody think of what potential side effects might happen with idempotency? Keep that in your heads, because you're probably right. We're going to go through an example. What happens without idempotency? So, my husband and I were driving through on one of our road trips, and we're on our way home, and I like desserts, right? So I pull up one of our bakeries in Las Vegas, which is where I'm based, and I'm looking at all the different cakes there are. And I'm like, yeah, I kind of want to order one so that when we get home, I'm going to have a cake, because I'm the dessert person, right? And so, who am I kidding? I'm going to get the world-famous strawberry shortcake. So I'm going to do this and place the order. So when we think about what is part of placing that order, we have to take a look at it from this perspective. There's going to be me, which is the client who's placing the order. There's going to be the website, which is Fried's bakery website. And we have the API. And time is flowing downward. That's just the scope that we're going to work within. Now, when I place that order for that delicious strawberry shortcake, I'm going to place that order. It's going to get to the website. Presumably, it's going to place it with the API. Now, at this point, we're driving from our road trip, right? And so I'm going to pass through a tunnel, much like this one. And I lose network connection, right as I'm placing that order. So when I lose network connection, I don't know what's happening in the background right now, right? I don't know that this order has actually been processed, and Fried's has accepted my order. Maybe they've started running, the mixers and have started creating the box to hold my cake. I don't know all of that because I'm still in the tunnel. Now, when I exit that tunnel, presumably I regain network connectivity. And what's going to happen here now is, depending on how Fried's handles that, I'm probably going to just resubmit that order because I want that cake. I'm going to get that cake. So I'm either going to see a really, something not so nice. Maybe I'll see like a timeout error, or this did not go through. I hopefully see something that tells me, hey, this didn't go through and you probably want to retry again. So that's what I do. I'm going to place my order. I'm going to have it go through. It's going to be processed, and cake is on the way. Yay, cake. But what actually happens if we zoom out here? Am I going to get one cake, or am I going to get more cakes? I'm going to get more cakes, because that first particular request that went through, that I didn't know went through when I entered the tunnel and lost connectivity, that actually went through. And so this is actually going to come through. I'm going to get 2 cakes. And I've had people come to me time and time again and say, Adrienne, you need to change your example because 2 cakes is not a problem. So just imagine now that this is your bank account being charged twice. This is a withdrawal, taking out money twice. This is anything else that's you not receiving 2 cakes twice. The whole point of this is that the intent of this request, my intent was not to order 2 cakes. My intent was to order 1 cake. But because there's no idempotency built into this system, this is the biggest side effect that happens. The biggest side effect is that duplicate requests are considered valid requests. And that is a pretty harmful side effect. Again, maybe 2 cakes is not harmful, but having you charged twice, getting it withdrawn twice, those are harmful side effects. So when you have things, when you have a particular request, when you have a specific intent not captured, that's what happens in a non-idempotent system. It has no choice but to say, hey, there's 2 requests here for 2 cakes. I'm going to go through and process it. So how do we actually apply idempotency then? What do we need to do to fix this problem? Well, there are 3 elements of idempotency that we need to consider in almost any system. So the first is an idempotency key. So this is usually generated by the client. This is something that needs to uniquely identify every request that we have. So this can be a unique identifier. This can sometimes be generated. This can be a hash of the event or a timestamp. Whatever that is, it needs to be something unique, and it needs to capture the intent of the request. That's the key, what we call the idempotency key. The next thing that we need here is an idempotency layer. So here, in the context of what's happening here, this might be on the API layer, this might be in the middle layer or middleware. There's even a tool or middleware layer that's called MIDI that deals with this. But this is what acts like a filter. So this is what decides what to do with that request. It's going to take that idempotency key along with the rest of our requests, and it's going to look at the information in it and say, what do I do with this? How do I deal with this? Have I seen this before? And then lastly, the last element of idempotency is a persistent storage, some sort of persistent storage to deal with idempotency. Because here, this is what stores our state. Here, this is the source of truth for our system. And it's here where it can also serve as checkpoints if you have a more longer running system. But this is kind of what does the check. This is when the filter, when it gets that idempotency key, is going to look at this persistent store and say, hey, have I seen this before? Or hey, is this a thing? And based on what is in that persistent store, that's what we decide how we're going to deal with this particular request. So now that we know these are the three elements of idempotency, we need a key, we need an idempotency layer to know what to do with it, and we need some sort of persistent storage that tells us what our source of truth is. Let's go back now to that particular example and see how we can apply idempotency. So same thing, I pull up Fried's Bakery on my phone, I look at the cakes. What are we ordering? Strawberry shortcake. Yes, somebody's paying attention. Strawberry shortcake, the world famous one. I'm going to order that same cake. And this time, I'm going to generate that key. I'm going to generate it off of the client. So that could be something like a UUID. It's now going to be part of our requests like this. That's the first major change, is we have a key that's going to be sent with the request. So now we have an idempotency key. The next thing that we're going to see as a change is we're going to see a little bit of change in the idempotency layer, which in this case would be the API. So what happens now is it's going to send that API, or send that request, sorry, with the key. It's going to say, hey, have you seen this particular thing before? And if it has not seen this thing before, then it's going to go, oh, I'm pretty confident that this is a request we have not seen before. So then it's going to go through and now actually run the rest of the request. It's going to place the order. It's going to do all of the things it will do based on it believing it's a valid request. What's also going to happen is that it's going to store that result. So that's very important because when we have something go through that's successful, we want to keep track of that. We want to know that this particular request has been sent and has actually been worked on. And so now, everything is going to go through. So let's say this has happened, right? The same thing happened. I entered a tunnel, and I did not receive that response due to network connectivity. This is now what the new initial request is going to look like. And now with idempotency built in, all subsequent requests are going to change and look like this. So next time I resend a request, what's going to happen now is it's going to say, hey, I have seen this before. It's checking the persistent store. It's going to say, I've seen this particular idempotency key. I've seen this request. We do not have to run this again. So sorry, Adrienne, you're not going to get 2 cakes. But your initial intent, the intent that you wanted to order a single cake, will actually happen. And it's now going to say, hey, we have this result. We've already seen this request. This is what we're going to send back. And no matter how many times I rerun this, because we now have this implemented, we have a persistent store that stores all of the requests that have been completed or have not completed but have been requested. We have an idempotency layer now that says, please first check the persistent store before you actually go through and just start placing cakes everywhere. No matter how many times I run this now, it will remove those duplicate requests, and it will actually only capture the intent and give me the single cake that I want. So that's idempotency in a nutshell. That's like the most severe side effect of idempotency is duplicate requests, but that is a big one. Now, if you wanted to try idempotency yourself, the one thing that I really liked here is the AWS Lambda Power tools. So they do have it for TypeScript, for .NET, I believe it's Python as well, Java. And what I like about this is that everything that I've told you today kind of maps to what they do as well and how they implement it in this particular library. So they have idempotency keys, which in this case you can do a whole hash of the entire event, or you can choose specific pieces of the event to be hashed, and that becomes your idempotency key. It has a persistent storage layer, which, of course, the default is DynamoDB, but that has since changed. Before, the default was DynamoDB, and it was only DynamoDB available. But now they have actually introduced a base class that you can abstract from and inherit from, and you can now bring your own persistent storage, which is pretty cool. So you don't have to use DynamoDB if you don't want to. So very quickly, the way you would start is you have this idempotent decorator, and you could very easily make your requests idempotent using importing this particular library and using idempotent decorators. Some of the other cool features here are that, sorry, my eyes are a little blurry at this moment. So the first feature here is that you can prevent multiple Lambda functions executions on the same payload during a time window. So for example, in that particular case where I was mashing the order button on the cake, if I was to do that, if there's a specific time window that you set that says, hey, if somebody is sending the same request within the span of, say, 30 seconds or a minute, you can automatically, with this, remove those duplicate requests and set up what those thresholds are that says, in this particular time frame, with this particular set of parameters, you can confidently say these are duplicate requests, so you can remove those out. Another feature that they have is that you can handle concurrent executions on the same payload. So let's say something was able to go through. You now have states as part of this, where it says if you send a particular request, you send another one very quickly, and it happens to go at the same time. There is a state that's called in progress that is going to be set to the first request, and you'll actually get an error back that says, hey, there's already a request that's in progress that's already happening, so it's going to remove that duplicate request. Another really, really interesting thing about this is that if you happen to use the DynamoDB table as your persistent store, what it does is it stores the state, and it also stores the function name as part of that, the idempotency key, the hash key. And why that's nice is that you can use a single table to kind of look through this. This makes it much easier to debug because you don't have to go through multiple tables. You can see which particular functions and which particular keys are possibly giving you trouble. And then lastly, you can actually set expiration periods for idempotency records. So the default limit, I believe, is an hour, but you can set that to be something different. If you have way larger scale, then you can set that to be a little bit faster, or depending on how long you need those records, you can set it for a little bit longer. So this is very important because, as you can imagine, the more requests that you receive, the larger that persistent store is going to grow. You're going to keep storing all of those keys, all of the results of those possible requests. So this is one thing to help reduce the bloat of that persistent store. And there's a bunch of other features. I highly encourage you to check out this particular tool. They have a whole section on idempotency, and it also shows you all of the different features that you can do to adjust or implement idempotency with your particular functions. Some other really great tools and libraries. There's obviously the Stripe API. So if you really want to see some good documentation on idempotency and how they are applied, the Stripe is a very, very good set of documentation that shows how to implement that. And their blogs are very, very good at explaining how they, in particular, have implemented idempotency in their particular requests. There's also something called Idempotent API. This is a more .NET featured, .NET focused tool, and this is also using an idempotency key in the header. So if you're using any .NET solutions, this is one way to, similarly to the power tools, be able to use an idempotent decorator and add that to your APIs. And then finally, Cisco. I work at Cisco. Cisco APIs. We do have a few products that do use idempotent requests. I'm currently in the process of trying to have them be all requests. So we do have some Cisco APIs there that do implement idempotent requests on most of the most important endpoints. So with that, that's it. That's idempotency. Thank you so much, Miami.
And while we have you for a couple of minutes more, I know that you said that you are in the midst of writing a book. Can we pre-order it?
Yes, you can. It's
Okay.
called Looks Good to Me, Constructive Code Reviews. It's currently on Manning pre-release. And yeah, it has 8 chapters available now. It's currently going through 3rd review, so cross your fingers. I don't have much more to change. But in total, it's about 11 chapters, and it talks about code reviews, the thing we all love and hate. I'm hoping for it to really improve code reviews everywhere. It's something that is so important, but so many developers dread them, and I'm trying to change that in this book. So feel free to check it out.
Wonderful.
Yeah. Sorry? Yes. It is, very much so.
We have about a minute or so for questions. If anyone has any questions, and what I would say is just be sure to repeat the question back so that the live stream can hear it.
Sure.
Any questions for the speaker?
I would have ordered another one. I'm sorry, based on the algorithm. Yes, that's correct. So I would tell my husband, I can order another one, but because I have fixed Freed's website, it's not going to give you that one. We're only going to get one cake. We're going to have to share it. And by share it, I mean I get 75% and he gets 25%. So for the live stream, somebody asked, what happens if you told your husband to order another cake with the changes that have happened in this system? And I said we would order it, but no 3rd cake is going to happen. No multiple cakes will happen.
I think we have 2 more questions. We'll take the one there and then the one over there, and then we will wrap.
Sure.
Pick up in there.
So in that case, after the expiration time which we have set in our algorithm, you can order another cake, right?
After the expiration time, you cannot order another cake. Is that what you're asking?
I can order another cake, right?
It depends how you set up the system. So yes, let's say you set up a time window for only 5 minutes, and I've sent in that request. It's stored it in the persistent store. After 5 minutes, if it sees my request again, it's going to count it as valid if you have set that time window to 5 minutes. That's a very high level. If you're only considering time window expiration, then yes, if you've built your system that way, it's going to count it as a different request.
And I think we had one more question up on our left.
Sure. That's a great question. How do you handle duplicate requests that are not necessarily a mistake? Can you give me an example? Like if I ordered between the span of a minute a chocolate cake and another chocolate cake, like I wanted 2, is that kind of what you're asking?
Yeah, or like me online shopping, a cardigan, one color, and I'm like, well, I really want it in another color.
Sure. That's a great question. So if I wanted a cardigan in one color and I said, you know what? I really like this cardigan, let me get it in another color and do it within the span of what could be considered a duplicate request. This is where the hash of the event would come into play. So let's say part of your order is now, first it's a black cardigan, and the next one is a camel cardigan. You could use that part of the hash in your order to now differentiate the request. Another thing is adding a timestamp into your request as part of the key. So making that key really, really unique. Instead of just generating a single particular thing, if you combine different things to make a very unique hash and add the timestamp, and if you have set up your system in a way that says this is a valid request because it's a different timestamp or a different idempotency key, pardon me, then that could be not mistaken for a duplicate request. So something like that, making the unique identifier very, very unique within that time frame could be one way that you could differentiate actual requests that are different.
Let's give it up for Adrienne.
Thanks.